So in our yesterday's session, we have started with the Verilog HDL. What do you mean by Verilog? What it is and how it is different from VHDL, and what do you mean by EDA tool? What is synthesizability and what is non-synthesizability, and how to declare your Verilog coding? What is module and end module keywords? Okay, and styles for declaring your ports. And we have seen two styles, and we have also seen input-output ports for this, and we have also seen the rules for declaring your identifier rules for declaring your identifiers. Okay, and also started with the discussion of abstraction layers levels, different type of abstraction levels, comments, number specifications. These are all things we have seen in our yesterday's session. Now in this particular session, let us start with data types discussion. Let us see what are the data types which are available in Verilog. Now, what do you mean by data type? Can anyone tell me? What do you mean by data type? Any idea or any idea? So basically, data type is nothing but what kind of data your variable can hold, whether it can hold a string data type or whether it can store a integer data type or integer, or whether it can drive a integer. So what type of data your variable can actually deal with, that is nothing but your data type. Okay, so any variable you are declaring in your programming language, any programming language, as far as I know, like C language or C++ or Python or Verilog or VHDL, any variable you are declaring, you cannot simply declare it. You should specify the data type of that particular variable so that the compiler will know that okay, this particular variable can deal with this type of data. Okay, so that's why we are going to use this data types. Okay, now, in this data types, we have different data types in Verilog. The first data type which we are going to discuss is net data type. And give me a minute, 1 minute, there is a background disturbance. Yeah, sorry for that. So, we are going to basically start our discussion about our net data type, and next we are also going to discuss about a reg data type. Okay, and we also have integer data type, and we also have real and time. So these are the data types which we are going to discuss: net, reg, integer, real, and time. And strings already we have discussed. String data type we have discussed already. Okay, so these are the data types which we are going to have in our Verilog, and we are going to discuss them: net, reg, integer, real, time, and string. Okay. Now let us see one by one. Let us try to understand the use case of each and every data type. Let us try to understand. So first, let us discuss about our net data type. Now, in Verilog, this net data type is used for basically physical connection of your modules, or it is basically used for connecting different modules or different designs. Okay, I will write down here. It is used for connecting different modules or designs, you can say. So basically, this net data type is used for physically connecting your modules or your designs. This net data type is used for. Now, this net data type, using net data type, we actually cannot store any value. Okay, so you should be careful here. Using this net data type, you are not actually storing any data. You are actually driving the data. Here, this is a very important point to be noted. So we cannot store any data in net data type. We cannot store any data using net data type. So what are we doing with this net data type? It is basically used for connecting your modules or designs, or it can use it to drive any values. Okay, if we are using a net data type, it is just like it will look like this. Let's say you have a module A and you have another module B, and if you want to connect these two modules, you are going to use a data type which is known as a net data type. Okay, and here this if A is providing the values to B, then A will act as a driver and B will act as a receiver. So A is acting as a driver and B is acting as a receiver, and A is basically driving the values onto this net. A is basically driving the values onto this net, and you can also say this driver as your source. So your source is basically driving the values onto the net, and B is receiving the particular values from the net. Okay, here net is acting as a bridge between your A and B. Okay, using this net, you can basically drive the data onto the net, and your B module can receive the data from the net continuously. A will continuously drive the data onto the net, and B will continuously receive that particular data from the net. Okay, using this net, we are not storing any data using this net. We are continuously driving the data onto the net. Okay, so if A continuously updates, the value inside this net continuously get updated according to the values which are updated by our module A. Okay, and coming to this net data type, we have again classifications. So the net data type is classified into different types. One is wire, next WAN, and war. So these are the classifications we have in our net data type: wire, WAN, war. Okay. First, let us try to discuss about our wire data type. Next, we will come back to other data types. Okay. Now, as the name suggests, wire, like it's like your physical wire. Okay. So this wire data type is also used for connecting different modules. Okay, I will write down here for use it for connecting different modules or designs. For example, the syntax for this is let's see the syntax for this wire. Wire is my keyword. Here wire is my keyword followed by the variable name, or the identifier. You can say W1. Okay, this is my identifier, or you can say it as a variable. So this is how I am going to declare my wire data type, a variable with wire data type. Okay. Now here one more important point is if I write w1 is equal to 0, I'm not at all storing the data inside this w1. I'm basically driving the data on inside this w1, and I cannot simply write w1 is equal to 0. I'm going to use one more keyword which is known as assign. So I should use this keyword which is known as assign for driving the data continuously into my wire. Okay, and here on the right hand side it is my source, which is continuously, it is a constant source which is continuously driving the values into my wire. And using this keyword assign, I am going to basically continuously update the values from the right hand side to the left hand side onto this particular wire. And if I write assign w1 is equal to a, and this a is my source now. Okay, this a is my source which is continuously driving the data to my wire. Okay, and this is my wire, and this is my keyword which I am going to use with my wires or net data types for updation of the values. Okay, and one more important point, I am stressing this many times because we are not going to store any data into the wire. We are continuously going to drive the value into the wire. There is a difference between that. Okay, so this was about your wires. Okay, wires are basically used for physical connections, and we will see with some examples how we are going to utilize them and how we are going to connect them. That and all we are going to see further. Okay. Now, is it clear up to here? Any doubts or any? Now, so if I declare a simple wire W, okay, if I declare a simple wire W, okay, then can anyone tell me how many bits it can drive? How many bits we can drive onto this wire is my first question. What is the size of, what is the width of this wire? Can anyone tell me what is the width of this wire? If I simply written wire W, then how many bits can it drive? Can we drive onto this wire? My question is, if I have declared a simple wire W, then what is the width of the wire, or how many bits can we drive onto this wire? My question is how many bits can we drive onto the wire? I'm not asking the value which is being driven onto the wire. I'm asking the default width of this wire that we can drive onto this wire. So here we can only drive one bit of data. Here we can only drive one bit of data onto this wire. Okay, if I simply declare wire W, then I can only drive one bit of data onto this wire. Okay, is it clear? Is this clear for everyone? So if I write simply, okay, so if I write simply W is equal to 3 tick binary 001, assign W is equal to 3 tick binary 001, then what is going to happen? Are we getting are we so do we get any compilation error in this particular case? If I write W is equal to 3 tick binary 001, do I get any compilation error? What do you think? Assign W is equal to 3 tick binary 001. Okay, width is 1 bit. Yeah, so my question is, if I write assign W is equal to 3 tick binary 001, do I get any compilation error here? Okay, here I am not going to get any compilation error. Okay, Here I am not going to get any compilation error. And what is going to happen is on the left hand side, I have only one bit of 1 bit capacity. This width is only 1 bit. Width is 1 bit. But on the right hand side, I can see the width to be 3 bits. Width is equal to 3 bits. Then what is going to happen is the LSB of this number will be assigned onto the left hand side. That is, only the LSB bit will be driven onto this wire. Okay, so let's say this is your wire W1 and only the LSB bit, that is 1, will be driven onto this wire. Is it clear? So if there is a mismatch in your data width also, there will be no issue in the case of Verilog. It is only the LSB bit will be sliced and it will be assigned or it will be driven onto this wire. Is it clear? Is it clear for everyone? Yeah. And in the case of VHDL, we will get a compilation error saying that there is a width mismatch, that we should be careful. But in Verilog, we are not going to get any width mismatch issue. Our LSB bit will be sliced. Okay. Now, coming to default value, which is being driven onto the wire. Default value driven on the wire. What may be the default value which is being driven on the wire? Can anyone tell me? So someone was saying from previous 2 minutes. So if we declare simply wire W, then what may be the default value that is driven on the wire? I'm not driving any value. Okay, I'm not driving any value initially. So what will be the value that will be driven on this wire? Exactly, Z. Okay, so the default value that will be driven on this wire is Z. Default value driven will be Z. And if you display the value of this wire also, you will get your console output as Z itself. Okay, and this Z is nothing but high impedance. This Z is nothing but high impedance. So in basically in Verilog, we have 4 values which are possible. One is 0 and another is 1. Next is X and next is Z. Only these 4 values we are going to observe in our Verilog. 0 is nothing but logic 0. 0 is nothing but logic 0 or false condition. And 1 stands for logic 1 or true condition. And X stands for unknown, X stands for unknown, and Z stands for high impedance. Z stands for high impedance. Now, logic 0 or false condition we know, logic 1 or true condition also we know, unknown means also we know, that is nothing 0 or 1. Now, what do you mean by high impedance? Can anyone tell me? So basically in Verilog, we use this Z or high impedance for describing this state, that is unconnected state. Okay. Let's say this is our wire. This is our wire where this wire is not connected. For representing this unconnectedness, we are going to represent it with Z. Okay. During our Verilog and during our simulations, anywhere if we left any port unconnected or if we left anything unconnected, we are going to get this Z. Okay, so if you see this Z, you must be able to understand that okay, I have missed something, I have missed connecting something. Okay, then in that particular case you are going to get Z. Z is used to represent that particular unconnectedness. Okay, so here also we have discussed that wire is used for connecting something, and if you are not writing assign W is equal to some value, then you are not driving any value, that is wire is unconnected. That's why the default value that is being driven on this wire is Z. Is it clear? That is a default value and the default size of this wire. Let's say if I write assign W is equal to -1. Assign W is equal to -1. Do I get any error in this case? Any guess, any idea? If I write simply assign W is equal to -1. Now, do I get any compilation error in this case? Okay, I'm not going to get any compilation error. Then what value will be driven on this wire? Value driven on this wire. Can anyone tell me? If I'm not getting any compilation error, then if I display this value of the wire, then what will be the value that will be displayed. So what is going to happen is compiler, it is going to perform 2's complement on this number. Okay. So 2's complement will be performed on the right hand side. 2's complement will be performed on 1, and the result will be stored, sorry, and the result will be driven on the wire, W. Is it clear? So this in Verilog internally it will be exactly, it is going to perform 2's complement. It is going to perform 2's complement on this 1, and the result will be driven on this wire. Okay. Now can anyone tell me what will be the value that is going to be driven on this wire? What is the numerical value that is going to be driven on this wire? I have given the answer. So 2's complement will be performed on 1, and the resultant will be driven on this wire W. Now, can anyone tell me what will be the numerical value that will be driven onto this wire? I will write down the question once again. Assign W is equal to -1. So these are the type of questions which we can get in the interviews also. So it will be very helpful if we try to understand it conceptually. So if I write assign W is equal to -1, I have already given the answer that the 2's complement will be performed on 1, and the resultant will be driven on the wire. Now what will be the numerical value? So conceptually I have told you. Then what will be the numerical value that is going to be? Now can anyone tell me what is the size of what is the size here? What is the size on the right hand side? What is the size here? Yesterday we have discussed about numbers, right? Now what is the size here? If I write simply -1, what is the size? 1 bit. No, it is 32-bit. We have yesterday we have seen, right? So if we don't mention any size, then it is 32-bit. And what is the base? Base is decimal, and the value is 1. Value is 1. Okay. Value is 0 0 0 so on 1. Okay, because 32-bit, right? Now, if we perform 2's complement on this number, what is going to happen? 0, 0, so on, 31 zeros followed by 1. Then, if we perform 2's complement, then what is going to happen? 1 followed by all ones. So, we are going to have, so on, 32 ones we are going to have. We are basically going to have 32 ones we are going to have. So on the right hand side, we have 32 ones, and on the left hand side, we have only 1 bit. Okay. And on the left hand side, we have only 1 bit, because I have told you the default size of your wire data type is only 1 bit. On the left hand side, we have 1 bit, and on the right hand side, we have 32 bits. Okay. Now can anyone tell me what will be the value that will be stored inside this W? So left hand side, assign W is equal to -1. Left hand side I have 32-bit value, 32 ones I have, and on the right hand side I have only 1 bit width. So my value of my W will be equal to simply 1, because LSB will be stored. LSB only will be sliced, because on the left hand side we have only 1 bit width capacity. So that's why LSB only will be sliced, and it is going to be given onto the left hand side, and if we display the value of W, it will be equal to 1. Is it clear? Is it clear for everyone? Any doubts or any queries? Exactly, remaining bits will be discarded. Exactly. This is a very, very important point. Okay. Now, so from this conclusion, we can come to know that wire is an unsigned data type. Wire is an unsigned data type. Now, what do you mean by unsigned data type? Unsigned data type in the sense wire cannot store the negative values directly. It is going to perform the 2's complement on that number, and it is going to store that number. Okay. Whereas coming to signed data types, they can store the values directly without performing the 2's complement. Whereas coming to unsigned data types, they can store, they are going to store the values by performing the 2's complement on the value. Okay, that is nothing but your difference between your signed data types and unsigned data types, and wire is your unsigned data types. Okay. Now can anyone tell me which statement will be executed first, whether the first one or the second statement? If I write assign W is equal to 0 and assign W is equal to 1, then which statement is going to be executed first, whether the first statement or the second statement? If I'm going to write assign w is equal to 0 and assign w is equal to 1, then which statement is going to be executed first? First one or second one? Okay, remaining people, any idea? Exactly. Very good. So basically, Verilog is a concurrent language. Verilog is a concurrent language. Any all the statements inside our Verilog will be executing parallelly. So these two statements will be executed parallelly. These two statements will be executed parallelly. And one more important point is Verilog is a concurrent language or parallel language, you can say. So any statements which we have written inside our Verilog, it is going to be executed parallelly. Okay, so these two statements will be running parallelly. Now, what will be the value that will be driven onto this wire? Whether 0 or 1. What is the value that is driven onto this wire? Okay, others? What will be the value that will be driven onto this wire? I have said you. So it is a parallel language. Both the values will be driven onto this wire. What will be the value that will be driven onto this wire? So at a time, what are we doing? We are trying to drive 0 and also we are trying to drive 1 parallelly. Okay, both operations are happening parallelly. So the value driven onto this wire will be equal to x. This is what it is happening because both at a time what are we doing, we are trying to drive 0 and also we are also trying to drive 1. Okay, so as we are trying to drive the values multiple as this wire is having multiple drivers. Okay, that's why the value that will be driven onto this wire will be equal to unknown. Okay, as this same wire, single wire is having multiple drivers. 0 is one driver and 1 is one driver. Okay, we have two drivers on a single wire. Okay, that's why what is happening, what is happening, the value x will be driven onto this wire. Okay, so this is the issue when we use our wire data type. When we use our wire data type, and to resolve this issue, we are going to use one more data type which is known as var. Okay, we use this particular data type var. So what is the issue we were facing with our wire data type when we are using multiple drivers with a single wire? Okay, then the value unknown is being driven. So that's why to resolve this particular issue, we are going to use another data type which is known as var for resolving this issue. So in the case of var, if we have multiple drivers, I will write down here, if we have multiple drivers also, if we have multiple drivers, then OR operation will be performed on the source. Will be performed on source values. For example, if I declare anything as var w and if I write assign w is equal to 0 and assign w is equal to 1. Okay, here 0 means 32 zeros and 1 means 32 bit 1. 32 bit 31 bits 0 followed by 1. Okay, so we should be careful. If you simply write 0 and if you simply write 1, it is going to take a 32 bit value. Okay, and so what is going to happen here, OR operation will be performed on the 0 and 1, and what is the resultant of this logical OR operation between 0 and 1? It will be nothing but it is equal to 1. So 1 will be driven onto this wire. 1 is driven on the wire w. Okay, here the OR operation will be performed. Okay, but if we are using a wire data type, if we are using a wire data type, then we were getting unknown because multiple drivers are trying to drive the same value. Sorry, multiple drivers are trying to drive the value onto the same wire. Okay, in that particular case we were getting unknown, and here we are not going to get unknown. The OR operation will be performed on the RHS side and that particular value will be driven onto the wire. Okay, is it clear? Next coming to WAND. Okay, next coming to WAND. What is WAND going to do is same. So in the case of war, it is performing OR operation, and in the case of WAND, it is going to perform AND operation. That's it. Assign A is equal to 0 and assign A is equal to 1 if we write like this. And if we declare our WAND A, then AND operation will be performed on these two values and the resultant will be driven onto this. That is 0 is being driven onto this A. Okay, this is how your WAND keyword is going to work. Is it clear? Where, war, and WAN, the differences, are they clear? Any doubts or any queries? Shall we move forward? Okay, great. Okay, now let us, this was about your wired data type, default value, default size. Okay, this small things you should know: what is a width and what is the size, default size and default value. Okay, these are the important points you should know. And what is the difference between your wire and WAN and war. Okay, these are small things which we should be careful with. Okay, next, coming to next data type, which is known as your reg data type. Okay, now, using your wired data type, you are not able to store any data. It is used for connections, and it is, you can basically drive the data onto this wired data type. So, if you want to store any data into a variable, then the variable data type can be of reg. Okay, reg is basically used for store the data. Okay, use it for storing the data. Use it for storing the data, and the keyword is small reg, small letters only. This is our keyword. Reg is our keyword followed by our variable name, let's say A or B or something. Okay, so in this variable we can store the data. Now, how many bits of data can we store? What is the width of our reg? Can anyone tell me what is the width of A? How many bits of data can we store inside this A? Exactly, one bit. Okay, we can only store one bit of data inside this A. And if we want to store more than one bit of data, then we are going to use a concept of vectors that we are going to discuss little bit later. Okay, now, and let's say initially if you are not storing any data inside this reg A, then what is the default value? What will be the default value? Any idea? Initially, if we are not storing any value inside our A, then by default unknown will be stored. Okay, so by default the default value of your reg data type is unknown. Okay, these two things you should know: one is the size, default size is 1 bit, and another is default value, which is nothing but x. Okay, now let's say if I write reg A is equal to minus 1 tick binary 1. Reg A is equal to 1 tick binary 1. Then what will be the value that is going to be stored inside this A? Can anyone tell me? Or let's say I will write simply 1 minus 1. Let's say simply I will write minus 1. Then what will be the value that will be stored inside my A? Exactly, minus 1. So the 2's complement will be performed on the right hand side, and the 2's complement result will be stored inside my A. Okay, so the 2's complement will be performed. 2's complement will be performed on one, performed here. Okay, and the resultant will be stored inside my left hand side A. Okay, so from this conclusion I can come to know that reg is unsigned data type. Reg is unsigned data type. Basically, reg is your unsigned data type. That is, it cannot store your negative values directly. Compiler will perform the 2's complement on the right hand side values, and it is going to store that value inside your reg. Is it clear for everyone? Shall we move forward? Any doubts or any queries in this? Great. Now, let us see one more data type, which is our integer. Okay, let us see about our integers. Now, coming to this integer, it is nothing but these integers are of 32-bit size. The default size of this, the size of this data type is 32 bits, and the default value is unknown. Okay, and it is signed data type, and this is signed data type. What do you mean by signed data type? That if you try to store any negative value into this variable which has been declared as integer, then the value will be directly stored without any performance of 2's complement. Okay, for example, if we are having integer m, now what will be the size of this m? Size of m is 32, and default value will be equal to don't care, and it is a signed data type. Let's say suppose if you are trying to store m is equal to -2, if you print this, you will directly get -2 only. Okay, there will be no 2's complement which will be performed on this number. Okay, this is nothing but your integer data type. Okay, and integer data type can be used for normal incrementing, or you can use it in for loops. Okay, for incrementing purpose, indexing. Okay, this and all things you can use this integer data type. Okay, next, and you cannot store decimal values into this integer. Like let's say suppose if you are writing m is equal to 3.14, and if you try to print this, then the value will be printed as 3.00 only. The decimal part will be truncated. Okay, you cannot store decimal values inside this integer. Okay, this we should be careful. And after this we have one more data type which is known as float. Let's say if I want to store any decimal values inside my variable, then I'm going to declare that variable as float. For example, float a, and a is equal to 3.14. Then I can store this decimal values inside this variable a. Okay, and the size coming to this is 64 bits, and default value is unknown, and it is a signed data type, and it is a signed data type. Okay, and this float data type is non-synthesizable. This float data type is non-synthesizable, whereas coming to previous data types, these are all synthesizable. Okay, from now I'm not going to mention this synthesizable or non-synthesizable. I'm only going to stress on the data types or the constructs which are not synthesizable. If I'm not mentioning that whether it is synthesizable or non-synthesizable, then by default they are synthesizable. Okay, here previously I was not saying whether they are synthesizable or non-synthesizable, right? So by default you can assume that they are synthesizable. Okay, and if I mention explicitly that they are non-synthesizable, then that particular constructs are non-synthesizable. Okay, so this was about your float data type. Yes. Now let us try to understand about another, exactly 32 and x. Yeah. Now let us try to understand about vectors, and let us stop this discussion. Let me add one more slide. Now, coming to one more important concept, which is nothing but our vectors. Okay, so vectors are nothing but collection of bits in a single location. And the syntax for this is data type followed by size followed by identifier. This is the syntax which we are going to use for our vectors, and the size is mentioned before the identifier. For example, reg, and how to give our size. Let's say if we want to have a reg variable which can hold 3 bits of data. This is our variable a, which can hold 3 bits of data. Okay, let's say this is 0 1 1. Okay, it can hold 3 bits of data. Now what are we going to do is we are going to have the indexes. For this we can have 0 1 2 as our indexes. So we are going to mention that particular indexes here within the square brackets. 2 down to 0 is the size, where 2 is the index given for the MSB and 0 is the index which is given for our LSB. Okay, and followed by the variable a. This is going to look like this. This is our vector, where it is nothing but a collection of bits in a single memory location, and the MSB index is 2 and the LSB index is 0. This is our LSB and this is our MSB. This is how we are going to give the size of our vector. Okay, and this representation is known as big endian, where if we are giving our MSB as higher index and LSB as lower index, then this particular representation is known as big endian. And if we mention this as reg 0 to 2a, then it will look like this. This is our vector where MSB is given a lower index and LSB is given a higher index, that is 2. This particular type of representation which we are representing is little endian, because we are giving MSB a lower index and LSB a higher index. This is known as our little endian and big endian. And there will be no change in your values. Just we are changing the indexes. That's it. We are not going to, it is not going to affect your values which are being stored inside your variable A. Okay. Let's see one example. For example, if we declare reg 2 down to 0 a, and if I write a is equal to 3 tick binary 1 1 0, then what is going to happen if you are writing reg 2 down to 0 a, then a variable a is being declared with how many locations? 0th location, first location, second location. This is 0th index 1 2. Okay, and if you are writing a is equal to 3 tick binary 1 1 0, that means for 0th index your value 0 will be stored, and for first index value 1 will be stored, and for the second index value 1 will be stored. And let's say if you are writing reg 0 to 2 a, and if you are writing a is equal to 3 tick binary 1 1 0, then what is going to happen is same, but 0 1 1, but the MSB is going to have the index as 0, and next is 1, and next LSB is going to have the higher index, that is nothing but 2. That is the difference. There is no change in the bit order or something, just the indexing is going to change depending upon the way you are going to declare. Okay, this is how you are going to use. Okay, is it clear? Any doubts or any queries in this? Time data type we are going to discuss when we are going to have the discussion on our simulation. Okay, so if I explain here it will be confusing a little bit, so I'm going to explain it when we are going to discuss about simulation everything. Okay, yes. So this was about my vectors. Now here I can also declare like this: reg 5 down to 3a. There is no rule that I should always use a 0 index. 1 minute, I'm getting a phone call. Yeah, sorry for that. So where I was, yeah. So there is no rule that always you should use 2 down to 0 or 5 down to 0 or 10 down to 0. Okay, you can also use random indexing like 5 to 3. That is what is going to happen if I write a is equal to 3 tick binary 0 0 1. Then what is going to happen? The value 0 0 1 will be stored inside this vector 0 0 1, where your MSB index is 5, 4 and 3. Okay, but normally you are not going to use this type of indexing because it will be confusing, and this is the standard type of indexing where your LSB is going to have the lower index value and MSB is going to have the higher index value. This is the standard type of representing your vectors and your indexes. Okay, now let's see one more example where I am declaring a vector reg 5 down to 0 a, and if I am writing a is equal to 6 tick binary 111 underscore 011. I can also use this underscores and this will not be compiled, and why I'm going to use this underscores is nothing but for spacing purpose and for clear representation. So I can use underscore if you are dealing with large numbers. Okay, basically you can group them. Okay, Now, if I am writing A is equal to 6 tick binary 111 and let's say this is my vector where 111 is being stored like this. Now, this has the index 0, 1, 2, 3, 4, 5. Okay. And let's say if I declare one more variable, reg b. Now, what I'm going to write is b is equal to a of 0. Then the LSB will be taken out from this and it will be stored inside my B. Or let's say if I want to access this fourth index, then I can simply write B is equal to A of 4. Okay. Then the value at the index 4 will be taken out and will be given to B. And if I write B is equal to A of 3, then the value at the index 3 will be taken out and will be given to B. Okay. This particular concept is nothing but this is known as vector slicing. This is nothing but vector slicing. Let me take one more example. For example, I can take another variable of reg 2 down to 0 c, and I can simply write c is equal to a of let's say 543, 5 down to 3. Then what is going to happen? See this index, the index values from 5, 4, 3. The values which are present in these three indexes will be taken out and will be stored inside this C. Okay, that means C will look like this. C is of 3 bits, and it is going to look like this 1, 1, 1. Okay, so this is how I am going to slice my vector, and I can take whatever the values which I need. Okay. Is it clear? This is nothing but my vector slicing. Is this clear? Any doubts or any queries in this? No. I can use this vectors with only my registers, and vectors can be only used with reg and wire only. Reg and wire only. You cannot use it with integers. You cannot simply write integer 31 down to 0 a. No, it is not going to accept. Compiler is not going to accept it. Okay, because by default integer size is 32 bits only. You cannot able to modify it. Okay, so it is not going to accept it. So you can only use vectors with reg and var. Okay, because there are only of 1 bit, and you can if you want you can increase the size. Okay, so you cannot change the size. You cannot change the size of integer or real, or you cannot use your vectors with integer, real, or any other data types. You can only use your vector concept with your reg and wire itself. Okay. Now let's say if I write reg 2 down to 0, if I write reg 2 down to 0 a, and reg b. Okay, let's say reg 3 down to 0 a. And if I write a is equal to 4 tick binary 1101. Okay, and if I write b is equal to a, then what is the value that will be stored inside my b? Can anyone tell me? Please take your time and please let me know. Yeah, integer it won't support vectors. That is what I read. Exactly, correct. Now, what is the value of b that will be stored inside my a? Can anyone tell me? Take your time and please let me know. Exactly. Only the LSB value will be stored, that is 1 will be stored. Okay. So if there is any width mismatch, the left hand side we have only 1 bit width, and on the right hand side we have 4 bit width. Then only the LSB bit will be taken out and it will be stored inside our B. So the value of B will be equal to 1. The value of B will be equal to 1. Now let's say if I write reg 1 down to 0 A, and if I write A is equal to 7. Can anyone tell me the value of A that will be displayed? What is 101? I didn't get it. No, not 101. Only the LSB value, because on the left hand side we have 1 bit and on the right hand side we have 4 bits. So there is a width mismatch. So from this 4 bits of data, only the LSB bit will be taken and given it to the B. Okay. Yeah. And coming to this question, range 1 down to 0, A is equal to 7. What is going to happen? What will be the value that will be stored inside my A? Can anyone tell me? There will be no compilation error. There will be no compilation error. And the value that will be stored is, and if I have written simply 7, so it is a 32-bit value. So on zeros, and it will be triple one. Like this, it will be having 32-bit value followed by triple one. And on the right hand side, only these 2 bits will be taken out and it will be stored inside our A. Because on the left hand side, we have a size of 2 bits, right? On the left hand side we have a size of 2 bits, so only on from the right hand side the 2 bits will be taken out. From the LSB the 2 bits will be taken out and will be given into this A. So the value of A is nothing but 1 1. It will be displaying as 1 1, 2 tick binary 1 1. Okay, is it clear? And if we display it, we will get the value that will be displayed is 3 in decimal, and in binary it is nothing but 1. Okay. Yes, so this is how we are going to deal with vectors. You should be very careful when you're dealing with your vectors, and especially with reg. So many of the freshers, what they will be doing is like, I've seen someone like we were doing some operators, like we were doing some addition operation or subtraction operation. I've told them to do something. So what they have done is they have simply written reg A is equal to 3 and reg B is equal to 4, and they have written simply reg C, and they have simply written C is equal to A plus B, and they were expecting the value of C to be 7. But do we get 7 here? So do we get 7 here? C is equal to 7. Do we get 7 here? No, we are not going to get 7 here. We are going to get 1. Why we are going to get 1? Because this is a 32-bit value, and at the last LSB bits it is going to have 0 1 1, and it is going to have 1 0 0. So the 1 will be stored inside this A and 0 will be stored inside this B, and 1 plus 0 is nothing but 1 that will be present inside this 1. This C. Okay, we are not going to get 7. So these are the common mistakes many of the freshers are going to do, okay, initially. So we should be careful in this when we are using our reg data type. We cannot simply write reg A is equal to 3, reg B is equal to 4, and reg C, because there are only of 1 bit size. Okay, in Verilog it will accept. It is not going to give you any compilation errors. It is going to just slice the bits according to the width requirements. But in VHDL, it is going to give the width mismatching, type compatibility issues. These are all things it is going to give you. Okay. So in Verilog, you should be careful in this particular things. You should be very careful in the widths. Okay. And especially if you are dealing with your reg, then it is recommended that your right hand side you represent with your base. Okay. Like if you want to store the value of 3, then you can simply write 3 tick binary 0 1 1. Okay, then you will come to know that okay, the right hand side is 3 bits and left hand side is only 1 bit. So you will be knowing that. Okay, initially. Okay. Yes, so that's about your vectors in Verilog. And in our next session, we will discuss about our arrays, and we have our port connection rules, and these all things we will discuss in our next session.